I messed up here. Okay, so our t is just dividing these. So that one's pretty big. These other ones. So it looks like it's the biggest one is the square feet of the home is the most significant.
Okay.
Because it's the biggest t value. Now to get the p value, you have to do something else with your distribution, but it doesn't ask for that, so we're not. I guess we'll just not go into that question there. So the next thing it asks for in part E is a 90% confidence interval. Sorry, good question.
What one would be the least? Would it be like the 9?
No, this is the most significant.
No, but the least one. Sorry, like 9.
Probably the minus point, the minus 0.23472. That one looks to be the closest to 0.
Okay.
So that corresponds to age.
Okay. So yeah, just ask for like least and most.
Yes.
Okay.
Oh, is it? Does it?
Yeah, just like right below it.
Oh yeah. At least significant is age. So at least and then most. And again, you can't tell from the coefficient. It's you got to have both of those numbers in there. Okay, so the next question asks about a 90% confidence interval, and this is a calculation. I got to look up here. Most of the time, these are just done for you. You don't. You almost never have to do these by hand. Confidence interval calculator, and then let's see if we can find the formula for this. Yeah, you're gonna love this one. Yeah. So that's a prediction interval. We don't want that. The confidence interval is not much better. Oh, it's above it. Okay. So the mean. We don't want the mean value. We want the interval on coefficient. I'm just looking up the formula. I don't have it handy. Do you happen to have it in your notes?
No.
Okay.
If we have to skip it, that's fine.
Yeah, I'd recommend that. Although it does affect the next question. Okay, which variable contributes information prediction or has a 95% confidence interval? That's from the formula.
If they both come from the same one, we can just jump to the next thing.
Yeah, the next one's more straightforward, believe it or not. Yeah. Okay, let me pull up the next one then. All right, so we're on to question 2. Okay, the number of car accidents on a particular stretch of highway seems to be related to the number of vehicles that travel over it plus the speed at which they are traveling. City has going to do some analysis on it. So they use the number of accidents as the dependent variable. That's Y. And the number of cars passing along the stretch of road, that's X1. And then their average speed is X2. And he found collected 30 pieces of data. You would actually collect way more than that if you were being paid to do this. That's not even close to enough for this. Okay, so again, here's the output. It's not the complete output. It's missing that ANOVA table with the degrees of freedom and the sum of squares of the regression and the mean square and the F. It's missing that. I guess we don't need to calculate it. They are giving me the coefficient, the standard error, and the t value. But I think this is more what you should expect to see, which is with the questions here. Let's take a look at the questions for us. Is this model useful in analyzing the number of accidents? So we actually do need to calculate that F value. So we start with degrees of freedom, and we know that there are 30 pieces of data, so that's 29. There are 2 variables in the regression, and then the error gets us to 27 because they have to add up to 29. So we're missing that mean square or MS column here, and then we're missing that F. So you get mean square by taking this 132072 and dividing it by 2. So that's 66,036. And then the next one is 274,025 divided by 27. And that's roughly 10,149. So your F value you get from dividing those 2 numbers. Your F is the mean square regression over the mean square error. So you take those 2 numbers, divide them, and you're going to get something close to 6.5, we'll say. Let's see what it is exactly. 6.507. And we need the p-value again. So that's where you go to your Excel, f.dist.right tail, and then you choose the F value, 2, and then 27 for your degrees of freedom for that. So let me get that number for us. All right, so wow, actually just barely, so 00493. So this is definitely less than 95% confidence means an alpha is 1 minus C. So it's 1 minus 0.95, so it's 0.05. And this is less than the 0.05. So we know that it is significant. It is useful because the p-value 0.00493 is less than the alpha level. So it does look like you're going to have to be able to fill in this ANOVA table with your degrees of freedom, calculate your M square by dividing, calculate your F by dividing as well. I know this isn't very interesting. I mean, I'm not interested at all in this, but that's where we're at. I mean, it's multiple regression. Just these problems aren't probably very interesting either. So part B is the coefficient of determination, and shoot, they do not give us that. Darn. Okay. So to do the coefficient of determination, there is a formula for that. So that's your R squared. And I want to look that up. It's based on the numbers in the ANOVA table, but let me check please before I say anything. Yeah. Okay. So the coefficient of determination is the sum of squares of the regression over the sum of squares total. So the sum of squares regression is 132072. And then the total, you just add up both numbers, 132072 plus 274,025. And let's see what you get here. Doesn't look to be that good. Yeah, 0.325, which isn't very good, but I mean, we don't even know. I guess, I mean, just by inspection, I mean, I wouldn't think that cars passing along a road and their speed is a good predictor of car accidents. I would think it'd have to do with like distractions in the car, road conditions, and other things. So that's maybe why this is so low.
Okay.
And then that's really what you should be trending towards in this course, which is like not how to do the calculations. It should be like, what does the output mean? And is it significant?
Okay.
All right, which is the most significant predictor in the number of accidents? So to answer this, we go to that other table with the t-value in it. So I'm going to grab those. It's never the coefficient, although I don't know why. I don't know why, but it's got to be one of the variables. You just look at which t-value is further from zero, and yes, its average speed is the most significant predictor because it's the highest t-value. Did you get any sort of equation sheet with this?
No. No, he doesn't give us.
Unbelievable. So the f value, so t squared equals f. So the f value is this number squared, and that's what I was asking, because I don't even know how you're supposed to know any of this, like if you've never seen it before. So why does that work? That's not really, I mean, that's important, but not for what we're doing. So it's just another like what it seems like. My perception is what they're trying to do is find a way to ask you questions on this assignment about the numbers, like how to do the calculus, rather than like they don't want you to do this calculation by hand because that's horrible. But then they're like, well, let's give him a partial output and see if he understands how they all work together, rather than like, what does this mean? Or like, is a car traveling at 70 miles per hour when there's 8 cars in a row traveling 70 miles per hour? What's the probability of an accident or something? The interpretation questions.
Yeah. No, it does seem like it's like showing you a table with missing spots and like, can you figure this out?
Yes. And I might even ask the instructor that, hey, is that what we're going to be doing on the tester quiz? Because that's fine, but I want to know. Or is it going to be using Excel to do the regression, or is it going to be, here's a regression output and answer some questions about it? Maybe it'll be all of it.
Yeah.
So I think that is it for that problem. Let me just double check that is the case. Yeah. Okay. What should we do next?
Could we do assignment number 5? Would that help?
We can start. Yeah.
And then just if we get through it, we get through it. And that'll just be the last thing. If we don't, we don't.
Let me see if I can get this to copy into Excel. Please work. Please. Of course it doesn't. All right. Yeah, I'm gonna have to I guess.
Is there another way we can? Yeah, because that's a lot for you to input. I don't.
That's fine. No, it's fine. I mean, we get time. It's up to you. Yeah, I do have to input all this information. So let's do that. So residence, sale price, bathrooms total, age, attached garage view. Okay. Yeah, I mean, this is just another Excel thing. So here, let me do this. I'm gonna mute myself. I'm gonna enter the data, and then I'll say hi when I've got it all done.
Okay, all good.
All right, I'm back and I'm going to share the other screen with the Excel in it. So sale price is your output, and then all the other variables are your inputs. And to do the regression, you go to data, you go to data analysis, and you do a regression. And it tries to pre-fill the cells based on what you did before. So you don't assume that that's right. Just change them each time. And you can't damage anything. Just if you screw up, just start over. There's definitely labels in that first column, and we're going to put the new worksheet in assignment 5. If I forget to send this to you, I do save these files. I think I had one from a previous lesson. We can you can always get them there, or I can always send them to you
Okay.
if you want to look at. So there's the output. Again, we kind of care about the R-square value. That's our coefficient of determination. If I could get back to where I can highlight it, that's usually useful value. Notice we've been sort of messing around with degrees of freedom. Sometimes having a table like this helps you to remember the formulas. You take the sum of squares, divide by degrees of freedom, get mean square divided by the other mean square gets you the F, and so on. And then you generally need these. And then we've been looking at a lot of T-stat stuff there for us. So the one that's most significant is the one that's furthest from 0. Looks like it's probably a attached garage, but that one's not even significant because it's not less than 0.05. Okay, so now let's answer some questions. So part A, it says to predict given the least squares regression sales, should the Excel print out? Okay, yeah. So here's your output. I mean, that's it. That's part A is the output. Part B, it says, is the model used for predicting sales at 90% confidence? So 90% confidence corresponds to an alpha level of 1 minus that. And then you're just comparing your significance, your p-value. This is really your p-value. Oops, this is really your p-value. You're comparing your p-value to the alpha level, and you would say, since p-value less than alpha, yes, it is significant. Something like that. That's part B. That's the only place you're looking.
Okay.
Part C. Part C is now asking for the most significant and the least significant predictor. So you're just looking for the maximum of these p-values. Let me make this a little bit bigger. You're just looking at the maximum p-value and the minimum p-value. We already said that the minimum one is AG, which is attached garage. That's kind of weird, but okay. The least significant is the number or the view. The view is the least significant. I mean, I don't know. Depends. I guess it depends. There's a house in every corner. So there's something for everyone. So I guess that would be how I would answer part C.
And again, so that's the other way. So it's p-value. It's like AG is the most.
Yes.
Okay.
Because it's the smallest p-value.
Okay, perfect.
Easy to mix those up, but they're the biggest and smallest. Okay. So then it says to use the following data to figure out the valuations for each of the 5 residences. Okay. So to do that, how do we want to do that? Basically, you're multiplying or you're using the intercept. You're starting with the intercept, but then you're multiplying the square feet coefficient times the number of square feet in that table, that 22.4. So the first, what is it, 22.4? I guess I got to enter this data now. Let me mute myself and I'll get back to you. So there's something interesting. Excel thought I wanted to alternate the green color in this data set. Really weird. Okay, so the predicted value, to get the predicted value, we take the intercept and then we add it to the these numbers here. And I'm going to try something. I don't know if this will work. Product this. I don't know if it'll do it because they're not in the same. Let's see if it works. That did work. Actually, I don't know if it worked or not. How would I know? I don't think it worked. Let's not do that. Okay, sorry. Trying to shortcut here. So we're going to take the second data value times this one plus bedrooms times the next coefficient or next number plus the value for baths times the next coefficient plus total number of rooms times this. Are you familiar with real estate at all where you live?
Not really. Like, I don't think, at least, I don't think I am. I talked to my mom and other people about it a little bit, but
Okay. It could be really interesting to sort of, I already messed up this formula. It could be really interesting to sort of like, figure out if like these actually matter. These things here. Sorry, it's just that these aren't really working for me. All right, let me do it differently. Bless it. It's just such a nightmare. So I'm just putting the coefficients up top because this will make it easier to do. In most statistical packages, you just give them the inputs and they give you the outputs. You don't have to do this manipulation that we're doing here, but nevertheless, that is what we're doing. So we're doing the sum product of this. Oh my gosh. Why is everything so difficult? Okay, so we're going to take this row, we're going to hold it, we're going to multiply it by the next row, and then we're going to always add this number here. All right, so there's our first prediction value. And there it is. And I'm just trying to shortcut how to do this with the Excel, but that you're just multiplying the numbers by the coefficients, you're adding the intercept, and you're getting a your output there.
So what would be would it be the best one would be number 4?
This is just the home, the estimated price of the home, sale price of the home. That's the most expensive home. It's got the most square feet. It's got the most rooms, but it doesn't have an attached garage or a view.
Okay, but that's all they asked for, right? Yeah.
That's it. That is completely it. Yeah.
Yeah, that is a ton of inputs though. Like for you, all the values you just have to.
It's just a lot, and you can see how it just can go bad. So you never want to do this stuff. Like in a work situation, like get the data. You make sure the data, and they call it data integrity. Make sure it's actually what you think it is and should be, and be find the smartest way to do it, not not brute force, which is what we did here.
Yeah. All right, well, I
So
think that's good.
great. Well,
Uh,
I hope you have a great, great time on your trip, and let me know when you need some help again.
Thank you, I appreciate it.
Okay, have a great day. Bye now.
I'll talk to you again soon. You too.